Go.
Hi guys, I'm Sai Satvik from Modern Education, and today I'm going to explain you how to find molecular formula as well as empirical formula with the help of percentage of the elements given in a compound. So let us get started. So let us go through two examples. So before going through the examples, I'll give you you must know few basic atomic weights. I mean the all atomic weights of all the elements to find the answer. I mean find the molecular formula as well as the empirical formula. So the basic thing we must know is atomic weights, and the second thing we must know just the simple maths, the division of decimals, all that stuff, and we must know how to find ratio, all that things. So let's get started with the examples. So you can see the first question here. In a compound, X is 75.8% and Y is 24.2% by weight. So here the elements name. So X and Y. Now here we are gonna write 75.8% and 24.2%. This percentage refers to the weight in that compound. So there are totally two elements which we don't know its name, which is one is X and other one is Y. This constitutes 75.8% of weight in that compound, and this 25.2. Just forget about the person. This is just a tabular column for easy understanding. And next, and if you read the question, if atomic weight of X and Y is 24 and 16. So atomic weight of X is 24 and Y is 16. I'll just write it as weight. Atomic weight is 24 and 16. Now we should find the empirical formula. Now how to find the number of moles in this, like how many moles are there, or how many moles of X are there in the compound and how many moles of Y are there in the compound. This is a formula, percentage, this which is 75.8 divided by weight, which is 24 for X. For Y it is 24.2 and 16. So percentage is 75.8 divided by 24. Here 24.2 divided by 16. So here the answer which we get is 3. It is 3.1. So let us write it here. So it is 3.1, and the answer here which we get is 1.5 approximately. 1.5. Now this must be given in simplest ratio because the number of moles cannot be in that of decimals. So let us divide these both by 1.5. 1.5 divided by 1.5 is 1. And 3.5 divided by 1.5 is approximately 2. So the ratio, which is simplest ratio, is 2:1. So X constitute 2 moles in the whole compound and Y 1 mole. So we can represent it as X2Y, and this is the empirical formula. Empirical formula. Unless we get the molecular weight, which is the whole compound, this whole compound's weight, we cannot find the molecular formula. We can only find the empirical formula. Now let us go to the next problem. Let us read out the next problem. In a compound, C is hit 52.2%. Let us write it here. Elements. C is 52.2% and O is 34.8%. And the other one is hydrogen. H is 13%. So this percentage indicates the weight which constitutes in the compound, and these are the elements. I just wrote the symbols. This is carbon, this is oxygen and hydrogen. Here they didn't mention the atomic weight because they gave the element's name, and we must be aware of the atomic weight, which I told you before. So atomic weight of carbon is carbon it is 12, oxygen it is 16, hydrogen it is 1. So now let us find the number of moles now. Percentage divided by weight, as I did for the previous one. So percentage is 52.2 divided by 12. Here 34.8 divided by 16. Here it is 13 divided by 1. So here the answer is 13. Here 2.1, 2.2. Here it is 2.2. And here it is 4.35, approximately 4.4. Here it's 4.4, 2.2, 13. So let us write all these values here: 4.4, 2.2 and 13. Now let us find the simplest ratio, because the number of moles cannot be in decimal, as I told you previously. Divide all these by 2.2. Let's check what answer we get. We are just finding the number of moles, don't hurry, because we gotta find molecular formula. So 4.4 divided by 2.2 is 2. Here it is 1. 13 by 2.2, 13 by 2.2 is approximately 6. So it is 2:1:6. So the empirical formula, I'll just write it as EF, for it is C2H6O1. So C2H6O is the empirical formula. Now let us find the empirical mass. So for carbon we know it is 12. 12 into 2 it is 24. The atomic weight of this carbon, which has 2 moles in it. So adding H6. Hydrogen it is 1. Atomic weight is 1. And there are 6 moles of it. So 6. And oxygen, the atomic weight of oxygen is 16. And there are totally just of 1 mole. So it is 16. So the answer is 46. So the empirical mass of this compound is 46. So in the problem they have noticed that they have given the molecular mass. I've told you that unless they give the molecular mass, we cannot find molecular formula. So in this problem they have clearly mentioned what is molecular mass. It is 92. So molecular mass is 92. So now we have to find the n factor. Now what is this n factor? So first let me give you the formula to find this. It is molecular mass divided by empirical mass. Here we get as 2. Now this n factor is the number of times the empirical mass should be added to get the molecular mass. It can also be used for the formula vice versa. It means the number of times the empirical formula must be added to get the molecular formula. So n here is 2. So the empirical formula must be added twice to get the molecular formula, because we've got to find molecular formula. So what is the empirical formula we found? C2H6O. So C2H6O multiplied by 2 gives you C4H12O2, and thus this is the molecular formula. Thank you for watching the video. Please do subscribe.